Hello, stream. It's that time again. It's Sunday. I don't feel like terribly overworked or like sick or whatever. That seems to normally be what happens on Sunday. Sunday is my seems to be my like crumple up in a ball day. But not today. Not math, but sometimes halves math. Have you played Blueprints? I've heard about Blueprints. You're like the third person to bring it up to me. And I want to play it, but I haven't played it yet. Just started it, you'd like it? I think, Brotito, I think you should play the Talos Principle. I think you would either find it like pedantic and not like it, or you would enjoy it a lot. I don't know. I would like to move over a little bit. Let's go right here. Okay. So we are continuing our kind of read through. Have you ever heard of Hydroneer? Yes. Not played it though, but I've watched Let's Game It Out and his videos and stuff on it. How do I want to do this? You know what? Let's go to this overlay. Turn that off. I can't decide how I want this overlay to go. Can you guys hear Maple? She's got a big girl bork, big girl. I've heard Blueprints. It's like a kind of like a not quite deck builder, but sort of deck buildery, like resource management exploration type thing. But then but that's kind of like a facade for kind of like a larger puzzle solving thing, which sounds interesting. My friend Blue asked me if I wanted to be on his stream and join him with playing it. And I'm like, yes, but I also want to play it myself. So also no. Here, let me see if I can get Maple to come inside. Give me 1 second. Hi. Either side or... Come on. All right, I was able to get Maple to come inside. So, last time we did math, which was like about a month ago, far too long. We were doing implicit differentiation. And we talked a lot about implicit differentiation. And now this week, I'm going to try and hit some applications of derivatives. So we're going to talk about related rates, and we're going to talk about like the first and second derivative tests. So basically, like related rates is kind of like how you might apply implicit differentiation. Let's see. I'm going to play this music. Yeah. So to kind of like related rates is how you might go about sort of like solving a problem where you have sort of like you have an equation that describes something, but then something in that equation is changing over time. Is kind of like perhaps the easiest way you can kind of begin to think about it. And so like in the kind of initial example that they give right here, you can think of like if we have a cone and the cone's filled with water or whatever liquid of your choice, like eyes emoji, and the liquid is leaking out of the bottom of the cone. And so what we could say is that the volume of the liquid in the cone is decreasing over time. It has some change with respect to time. And that change with respect to time, we can characterize as the derivative of the volume with respect to time. And so if we know how much the volume is changing by, then we can differentiate it with respect to time. And we can instead have like a new equation that relates how much the volume is changing by to the change in the height with respect to time, as well as the change in the radius, like of the top of the cone with respect to time. And so we can kind of figure out other things about the situation based off of like the equation that governs the thing that's changing with respect to time. And so if we go ahead and look at an example here, and so the variables x and y are both differentiable functions of t and are related by the equation y equals x squared plus 3. Find dy dt when x is equal to 1, given that dx dt is equal to 2, and x equals 1. And so if we go back even further, whenever we kind of initially started this whole like calculus course business, you know, I made a very clear point to say like, yeah, for a while we're going to be differentiating with respect to x, and all that stuff, but don't be fooled. Like, differentiating with respect to x is not like special. I mean, it's special in the sense that x is kind of usually what we refer to as like the spatial dimension that goes along the horizontal axis, but you can differentiate with respect to any variable so long as it kind of like suits your means, essentially. And so like for this given equation, or for this given question, if we can start with y is equal to x squared plus 3, then they're wanting us to find dy dt given this information here. And so if we want to find dy dt, well then we should differentiate first with respect to t. And so if we do that, then the derivative of y will just be 1, but since we're taking the derivative with respect to some variable other than what we're differentiating, we get this extra dy dt term. Same thing here, the derivative of x squared will be 2x, but since we're differentiating with respect to a different variable than x, we get this extra dx dt term. And the derivative of a constant is always 0. And so we get this new equation that dy dt is equal to 2x times dx dt. And so we can go ahead and plug these values that we were given up here into that. And so if we plug in that dx dt is equal to 2 and x is equal to 1, then we can get that dy dt is equal to 2 times 1 times 2, which gets us 4. And so dy dt is equal to 4. And so that's all well and dandy. I like these questions though. Whenever I like these questions more that kind of give us more of like a physical example. I feel like what these related rates problems are really good for is kind of like examining like a real world scenario. And so here we have another problem. It says a pebble is dropped into a calm pond, causing ripples in the form of concentric circles, as shown in figure 2.3.4. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area A of the disturbed water changing? And so, we're talking about the area of like the disturbed water. And so that area, if it's like a concentric ring that's expanding outwards, is going to be a circle. It's going to be the area of a circle. And so we can start with A equals pi r squared to kind of be like our equation that governs the sort of situation that we're describing here. And so if we know that the radius is changing with respect to time, then we can differentiate this equation with respect to time, where our variables are kind of the area and the radius itself. And so that would get us dA dt is equal to pi times the derivative of r squared with respect to t, which will be 2r dr dt. And so then they're saying, okay, well, when the radius is, so the radius is changing at a constant 1 foot per second, and when the radius is 4 feet, what's the total rate? What is the rate that the area is changing? And so basically, given that when r equals 4, and that dr dt always is equal to 1, then what is dA dt? That's basically like what they're asking us here. And so then we can plug in these values for r and dr dt. And so that'll be pi times 2 times 4 times 1. And so that'll get us 8 pi. And so the area that the area that the disturbed water is changing is going to be like 8 pi, what was it, feet squared per second. Oh my goodness. I think my life just flashed before my eyes. Turn this down a smidge. Wow. Hi, Toxie. So yeah. More problems. We can do more examples. Let's just jump down to the section questions. Look at all these word problems. Fantastic. Okay, here's kind of like a classic one. Depth. A trough is 12 feet long and 3 feet across. Its ends are isosceles triangles.
Do you like roller, Mike?
Did you hear about the Fentanyl X Meta Room tour? I haven't, but that sounds like a good time, and if they're coming near me, I would go.
Ah, Roller Mike, the perfect blend of wheels.
Why did he put why does he have Chinese at the end of his sentence?
I suppose it could provide a
Evil Talos, don't speak Chinese.
So yeah, I like it enough to maybe incorporate it into leaving the scene of a gnome caper scenario. Gunlun Mike Feng Xiao Nang Jia.
What did he say? This better not be fucked up, Evil Talos. Roller Microphone Capsule Enterprise. That's what Google Translate thinks. Google Translate thinks that translates to. Roller microphone. Okay. So yeah, a trough is 12 feet long and 3 feet across the top. Its ends are isosceles triangles with altitudes of 3 feet. Oh, for some reason I was like, but wait, if this is 3 feet and this is 3 feet, then is that isosceles or is that equilateral? It looks equilateral, but it's not equilateral, because then this is right here is going to be like 1.5 square roots of 3 or something. Okay, and so here, let me copy this over into here. I love related rates. These are some of like my favorite calculus problems. And so it says water is being dumped into the trough at 2 cubic feet per minute. How fast is the water level rising when the depth h is 1 foot? So to be able to solve this problem, we need to describe the volume of this trough as like in terms of this height here, h. Okay, apparently this is roller mic. Evil Talos is a fan. Roller microphone. Okay. So how are we going to describe the volume of this with respect to h? And so I guess first, so what we need to do is we need to describe basically like the triangular cross section as a variable of h. And so I guess what we can say is, okay, can I flip this over? No, I can make it really short, but I can't flip it over. Rotate. Vertical. Sweet. Okay. So I guess what we can say about this triangle is that like if we've only filled the triangle up to about here, then this smaller triangle down here will be similar to the larger triangle. And so they're similar, which means that there's some proportion between the two that describes them. And so we know for the larger triangle, it's 3 feet tall and 3 feet across the top. And so that means that for the smaller triangle, if it's h tall, then it should just be h across the top as well. Because if we were to set up this proportion, it would be like this side is like the base is to the altitude, so 3 is to 3, as the base is to the altitude. And if we say that this base is something unknown, well then it would be base is to h. And that means that if we were to solve this out by like cross multiplying and stuff, then we would get 3b is equal to 3h, And so h must just be equal to b. And so the height, the altitude and the base of this triangle in here are just the same thing. Hey, Jasu. And so then the volume of this prism then, for a given sort of like cross-sectional area of this triangle, is just going to be the area of this triangle times 12 feet. So basically like it's going to be like you get this triangle and you extrude it out, that 12 feet. And so the area of this cross-section is going to just end up being like 1/2 h squared, and then times 12 to kind of get it in terms of the entire trough. And so the volume of water in the trough is a function of the height of the water, and it is just 6h squared. And so then, if they then tell us water is being pumped through the trough at into the trough at 2 cubic feet per minute, then how fast is the water level rising when the depth of h is 1 foot? And so what they're telling us is that dv dt is equal to 2 feet cubed per minute, and that at a given time, the height reaches 1 foot. When the height is 1 foot, what is dh dt? That's what we want to figure out. Hey, Sorrel. And so if we want to figure out what dh dt is, then we're going to need to take the derivative of this equation here with respect to time. And so we start with v is equal to 6h squared. And so if we differentiate both sides with respect to time, then we get dv dt over here, and we get 6 times 2h dh dt. And so dv dt is equal to 12h times dh dt. And so if we plug everything in that we're given, then the question is, can we figure out what dh dt is? And so from all of this, we get 2 is equal to 12 times 1 times dh dt. And so then if we divide both sides by 12, then we get that dh dt is equal to 1/6 of a foot per minute. Per mim. Foot per min. And so that was part A. How about part B? And so for part B, it says the water is rising at a rate of 3/8 of an inch per minute when h is equal to 2. And so they're saying dh dt is equal to 3/8 when h is equal to 2. And then find dv dt. And so that's what we got to do for this next part. And so same idea though. We have v is equal to 6h squared. And so dv dt is equal to 12h dh dt. Same thing we just did. We're just kind of differentiating this implicitly. And so then if we plug in 3/8 for dh dt and 2 for h, then what do we get? We get 12 times 2 times 3/8. 12 times 2 is 24, times 3 is 72. And so this is 72 over 8, which is 9. And so dv dt is equal to 9 cubic feet per minute. And so, kind of, a significant portion of this question was just kind of getting that initial setup of like, okay, so like, I looked at the question and then I sort of read the first problem, and then I was like, okay, well, we want to know, like, as we're filling this up with water, or as water is kind of draining out of it, really the volume is changing with respect to the height of the water. Because it's not like we can like fill the water up from left to right without breaking gravity or anything. Not that we can't do that, or not that I can't do that. You might not be able to. But so that's why you kind of need to get the volume as a variable of h rather than anything else. Even though you can otherwise normally just like find the area of the base and then multiply it by the height. Okay, what's next? What should we do next? Moving a ladder. Construction. Oh, this problem here. Okay. I remember looking at a problem like this with a student at some point, and I remember thinking something was really weird about this problem. If it was just fluid, ferrofluid can be filled up sort of left to right way. Yeah, that's true. Just need a big ass magnet. Put it in like an MRE or MRI. MRE is like the food,
Brian?
right? Brian? Roller microphone.
Oops,
Capsule
something
Enterprise.
went wrong there. Forget what I said at the end. My language module sometimes gets knocked out of place. Anyway, roller mic is kind of cool.
Good save, Evil Talos. So yeah, I want to look at 23. I remember thinking something's really weird about this problem. Because for this problem... Alright, Maple. Alright, Maple. Here, give me 1 second. Hey! Stop, bird. Dang. Boo, I want Katie. Where is Katie? Katie! 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 Katie, come here! Hey, come here! Can I get the girl? Look, it's Katie. In my head, Katie is like the platonic ideal of a dog. Alright, Katie, thank you. You can go. You can go if you want to. You can go. You want more pets? Okay, you can have more pets. Good girl. Good dog. Oh, what? You want to get up in my lap now or something? Let me not show my face here. Katie. Oh yeah. Oh yeah. He's a good dog. Katie, you're on the cat cam. Do you know that? You're not a cat. Katie, would you like to sniff us the microphone? She's all blown out because of my my stage lighting. Look at her, she's so dog-shaped. She gonna sniff us? I don't think so. Okay, would you like to go now? Bye, I hate math, bye. Okay, bye. Okay, so. A winch at the top of a 12-meter building pulls on a pipe of the same length to a vertical position, as shown in the figure. The winch pulls in rope at a rate of 0.2 meters per second. Find the rate of vertical change and the rate of horizontal change at the end of the pipe when y equals 6. And so, if I remember correctly, the thing that's weird about this question is that because this pipe is like a fixed length, it's like the pipe is going to like rotate up into position. It's pulling at a negative rate, so it's pushing it down. No, that just means that the length S is decreasing. But you do make a good point. It says that it's pulling at a rate of negative 0.2. And so I would say that the poles and negative equates to pushing, but I think from the picture I interpret it more as S, this length here, is decreasing by 0.2 meters per second. So like in my head, like my physics brain thinks that like, okay, the like S is essentially like the resultant vector of the motion towards the top of the building, but because the pipe has to kind of move in a circular arc and can't move directly from the point where it is right now towards where it meets the top of the building, dx dt and dy dt, like the magnitude of them both together as a resultant vector, is actually going to be moving perpendicular to the end of the pipe, and it's going to be greater than S. And so there's like some level of like, this question breaks my like initial intuition. Because like part of it's like, you would kind of like, based on the setup, you kind of like want the math to imply that the tip of the pipe is moving directly towards the top of the building like this. But it's not. It's actually moving like in a circular... That was terrible. It's like moving in like a circular arc towards the top of the building. And since the actual vector of its motion is going to be more perpendicular to the tip of the pipe at the time of motion, I think the like magnitude of like dx dt squared plus dy dt squared, and then you take the square root of all of that, is going to have to be greater than ds dt. Which is all like which is all frankly irrelevant to the problem actually. But it's just like I like to come into these problems with like an element of intuition to begin with, like kind of like what I'm expecting the answer to be. And I think the first time I saw a problem like this, I was like, okay, well then, you know, dx dt squared plus dy dt squared, and you take the square root of all of that, is going to be equal to the magnitude of ds dt. It depends if the pipe is fixed at the bottom. I believe it is. It's the pipe is being pulled into a vertical position. It doesn't explicitly state, but I do feel like it's implied. Okay, well, let's figure this out then. So, kind of thinking about this in a coordinate plane, the distance, so if we're given ds dt, then let's find an equation for s. And so s is the distance. So s is distance from 0, 12 to x, y. And so that would give us that s is equal to the square root of just x squared plus y minus 12 squared. Yes. But also we need this to, we need x squared plus y squared to equal 12 squared, always. So x squared plus y squared is equal to 144. Basically the distance from the origin to wherever x squared plus y squared, or to wherever x comma y is fixed at 12 meters. I could say that the square root of this is equal to 12. But I think this could be useful, because if we're saying that s is equal to the square root of x squared plus this stuff, if I FOIL this out here, then I get y squared minus 24y plus 144. Oops. 6 hours and 15 minutes ago, it was 420. Damn, that's true. For me, that was only about 4 hours ago. Or, about 16 hours ago. Also, it's 8:15 here. And so, it's actually like 5 minutes from now and then 6 hours ago, so 5 hours and 55 minutes. But the minutes should be correct. Is it not 8:15? I don't know. Okay, but so here something cool kind of happens, I think. Because since x squared plus y squared is equal to 144, because it's fixed at this distance from the origin, since this must always be true, I think we can substitute this, can't we? Can't we substitute this value of x squared plus y squared into this equation for the length s from 0, 12? And so that would give us 144. And then this is minus 24y. Plus 144. Which would seem to imply that the length of s really only depends on y. How high up we are. I feel like we should be able to make it depend either on x or on y. It feels weird to me that this distance here isn't dependent on the height, or isn't dependent on x at all, but x and y are not independent. And so I guess in a way it does. Because if you pick any value of x, it should fix the value of y, which will then fix the value of s. Okay, well then, at any rate, now we need to figure out what ds dt is. Or I guess what's what's the question? Find the rate of vertical change. So they want us to find dy dt. So find dy dt, given that y is equal to 6, and that ds dt is equal to negative 0.2 units per second, meters per second. And so first we got to figure out what the derivative of this is with respect to time. And so ds dt, and then this guy we're going to have to differentiate by the chain rule. And so you could think of this like as some function of y, and we're taking the square root of that. And so first we'll kind of differentiate the outside function, the square root. And that'll be, what, 1 over 2 times the square root of 288 minus 24y. And then we multiply by the derivative of the inside, which will be minus 24 dy dt. And so if we do a smidge of simplification, then the 2 can go into the 24, and we get negative 12 over the square root of 288. Or actually, we can probably factor something out of this radical. The greatest common factor between 288 and 4. Is it 12 or is it 24? I think it's 12. No, it is 24. You can just factor 24 out of this. Okay, well, so you can factor 24 out of those numbers. But 24 is not a perfect square. So what's the largest perfect square that comes out of both of these? 100, no. Just 4? That's kind of lame. Okay, Well, so we can pull 4 out of this, which will, I guess, make this 2 square roots of 90. What? No, 144, 72. 72 minus 6y. And then this becomes 6. And then that's times dy dt. And so now we are ready to solve. I'm waiting. You had 1 times negative 24 over 2 times 4. Isn't that negative 3, or did I biff it? We pull out a 4 from inside the radical, which, to pull it out of the radical, we have to take the square root of it. And so it would be 2. And so 24 divided by 2 times 2 will be 6. My bad, no problem. You're usually right, so. Negative 0.2 equals negative 6 over the square root of 72 minus 6 times 6 times dy dt. 72 minus 36 will be 36, which makes 6. Negative 6 divided by 6 will be 1. And so 0.2 is equal to... Wait, so negative 0.2 is equal to negative dy dt? And so dy dt is equal to 0.2? See, I told you there's something fucky with this question, because that doesn't seem right to me. If the distance from this point to this point... Okay, hold on. If the pipe is 12 meters long, right, because this is why I was talking earlier, where it's like, even though like they're describing S changing like linearly between like 0, 12 and x, y, it's actually not changing linearly because the pipe has to, like the tip of the pipe has to move in a circular arc. And so I think that this doesn't necessarily have to be equal to 0.2. It's just, it's equal to 0.2 when y is equal to 6. But if y is smaller, then like, or if we were lower to the ground, y would be increasing faster. And if we were higher off the ground, y would be increasing slower, which does check out. But it does just, it feels very strange that we're describing the linear distance between 0, 12 and x, y as decreasing at a rate of 0.2 meters per second. Yet we can see at this time, we're moving upwards by 0.2 meters per second. And we're also moving horizontally, like to the left by some amount as well. Which means that the tip of the pipe is moving at a rate that's greater than 0.2 meters per second. Which is exactly what I talked about earlier. And even once I got the result, it still feels weird. Does anyone agree with me? Do we feel good about this? I feel decent about this. Are you moving horizontally at y equals 6? Yeah. There would be some component of us moving vertically and us moving horizontally. We could find it if we differentiated this with respect to t. Actually, would that work? Yes. Yeah, it would. That would imply that we're moving like at negative 0.2 meters per second. Oh, it's part of the question? Oh, and horizontal change. Oh. For some reason, I thought we just had to find the vertical change. Okay, well, so now if we take the x squared plus y squared equals 144, and we differentiate this with respect to time, then we get 2x dx dt plus 2y dy dt is equal to 0. And if y is equal to 6, then we'd get x squared plus 36 is equal to 144. And so x squared is equal to 108. And so x is equal to 2 square roots of... No, that would be 59. Half of that's 59. No, half of that's 54. 27. 2 square roots of 27, which is 9 times 3, so it should be 6 square roots of 3. Because this is 36 times 3. So yeah, 6 square roots of 3. And so this is 2 times 6 square roots of 3 times dx dt plus 2 times 6 times 0.2 equals 0. And so this is 1/5. And so this is 12. This will be 12 over 5, and I'll subtract that to the other side. And so we get 12 square roots of 3 dx dt is equal to negative 12 over 5. And then I divide both sides by 12 square roots of 3. Consider 6 is exactly half on the pipe length. You likely have no horizontal shift at that time point, purely based on intuition. I disagree. If the pipe is fixed at a point, here I can turn on my cam for this. If the pipe is fixed at a point, if this is rotating, even if we're like only half the length of the pen up in space, if we continue rotating up towards a vertical position, there is no way that the tip can only be moving vertically and not at all be moving horizontally. The only time that it could only be moving vertically and with 0 horizontal shift is if it's starting at a position that's perfectly flat, so y would be equal to 0. And then at that point it would rotate only upwards, or then it would only be moving upwards from that position. At that instantaneous moment in time. And so if we divide both sides by 12 over root 3, that would be the same as like multiplying by 1 over 12 square roots of 3. And so the 12 on top and bottom could cancel. And so this would be negative 1 over 5 square roots of 3. Let's rationalize this like some sort of barbarian. And we get root 3 over 15 is equal to dx over dt. So the tip of the pipe is moving vertically by 0.2 meters per second and horizontally by the square root of 3 over 15, or to the left rather, to the left by root 3 over 15 meters per second. Okay. It's still, I understand it, I think, of why it would be possible for one of them to be greater than ds dt. I don't know, it still feels very weird to me. To maintain this like fixed change in distance over time between the top of the building and the tip of the pipe, I think it does make sense to me at some point that the tip is going to have to essentially move faster, either vertically or horizontally, to maintain that fixed change in linear distance. I don't know how you can even have a fixed change in linear distance if the tip of the pipe is forced to move through a circular arc, though. I don't know. It's a weird question, but that I think it makes sense. Like, it's the sort of thing, like, it's funny because, like, you can so easily do this in real life where you just, like, stand at the top of the building and you just have a rope connected to a thing at the bottom of the building and you're just pulling up on the rope. And, like, this is exactly what you would be doing. Like, translating this change in, like, linear length to the, like, the motion of a circular arc of something. But it's still just, I don't know. Something about the math seems surprising to me, I guess. Let's see. What's another good question? This one looks maybe interesting. Figure for 30. Repeat exercise 29. Okay, well, what's 29? A man 6 feet tall walks at a rate of 5 feet per second away from a light that is 15 feet above the ground. Oh, so it's this figure. A man 6 feet tall walks at a rate of 5 feet per second away from a light that is 15 feet above the ground. Okay. When he is 10 feet from the base of the light, at what rate is the tip of his shadow moving? Oh, this is interesting. Do you know anything similar to NL solve that solves when the solution is a curve, not a point? I'm not sure what NL solve actually is. Non-linear solve, a type of numerical library. I'm not very familiar with like the programming side of math, admittedly. Worth a shot? Absolutely. Okay. So this is going to be kind of like another, we can describe the length of his shadow Or I guess we would want to try to describe the position of the tip of his shadow as a variable of his distance away from the light pole. And we can use the fact that the triangle here from the tip of the shadow to the top of the light pole will be proportional to the triangle here of the tip of the shadow to the man. That's probably how we'll go about this. Let me get this business in here. Where'd my snipping tool go? I think it's because I close it every time. Okay. Well, what do we want to know? We need to put some variables on here. Let's say the This is gonna be something like okay, well let's just first say, so this is gonna be 15 is to, let's call this distance here b. And so 15 is to b as, let's say this distance, let's call it a. And so this will be equal to 6 over a. And then well, so if they're walking at a rate of 5 feet per second away from the light, we should probably describe this in terms of like this distance right here then. And so this is what's changing at a rate of 5 feet per second. And so let's call this L. I still think we're going to need to somehow describe this entire distance here. I'll still call that A, I guess. And then the rate that the tip of the shadow is moving at would be the change in A with respect to time. And so we're trying to find dA dt when L is equal to 10 and dL dt is equal to 5 feet per second. And so that's our problem statement for part A. And so let's go ahead and try and set up our proportion now in terms of this stuff. I guess now this distance here that we need for our smaller triangle will just be a minus L. And so that gives us that 15 is to a, as 6 is to a minus L. And so let's go ahead and set this up and solve explicitly for a. And so we cross multiply. That gets us 6a is equal to 15a minus 15L. Hi, Epic. You know, Epic, a lot of people have been talking about blueprints lately. It'll probably happen soon. Good. Okay, if I subtract a from both sides, or 15a, I get negative 9a is equal to negative 15L, which tells me that a is equal to 15L over 9, which would be 5 over 3L. And so, the a dt is equal to 5/3 dl dt. There is no L in this equation. And so I didn't have to know that L is 10. Does that make sense to me? If hold on. If the distance from the pole is changing at a fixed rate, do I expect the tip of the shadow to also be moving away at a fixed rate, but just like 66% faster? Scratcher says, sorry for the interrupting, teacher. I'd like to wish you and chat a happy Easter. Happy Easter to you, Scratcher. Oh yeah, and happy Easter to everyone else if you celebrate Easter. Hope everyone is having a wonderful bunny themed Sunday. I think this does make sense to me, that the tip of the shadow will be moving away at a constant rate relative to how fast we're moving away from the pole, but that it would be moving away faster than I am. Because like as the triangle that needs to be similar gets longer, then like the proportional length of the base of the triangle needs to get longer as well. But it wouldn't increase like exponentially, or it wouldn't increase non-linearly. Which if there was a factor of L in there as well, then it would change fast. That would imply that it's changing faster and faster the further we get away from it. Which I don't think is true. I think this is correct. So yeah, that would mean that dA dt is equal to 25 over 3 meters per second. When he is 10 feet from the base of the light, at what rate is the length of his shadow changing? Is that different from the tip, like the speed that the tip of the shadow is moving? I mean, yes, it will be a different quantity, but I think part of the numbers are like very similar. Because the length of the shadow is just A minus L. And so I'll call the shadow length, capital S, is just A minus L. And so ds dt is going to be dA dt minus dL dt. Which implies that the length of the shadow is also changing at a fixed rate, which is irrelevant to how far away we actually are from the pole. That feels like an interesting result to me. And by interesting, I mean like maybe it's not true. But at the same time, it feels like the math checks out. And so that would be 25 over 3 minus 10. No, minus 5. We would have been in trouble if it was minus 10. 5 would be 15 over 3. And so 25 minus 15 is 10. And so we get 10 over 3 feet per second is how fast is the speed that the length of the shadow is changing. And so basically it's the length of the shadow is changing at the same rate as how fast the tip of the shadow is moving minus how fast we're moving towards the tip of the shadow, which makes sense. Because if we're moving to the right at 15 over 3 meters per second, and the tip of the shadow is moving away at 25 over 3 meters per second, then that means from us, uh, 5 to 15 is equal to A minus L to 1. Yeah, it should be... Is that what I'm saying? Either way, I think it's fixed. A minus L to A. Yeah. Yeah. Big triangle, 3 times the size. Yeah, because this would be 5. Because we're 10 feet away. I don't know. If we're walking away at 5 meters per second, then that seems to imply that the rate that the tip of the shadow and the length of the shadow are changing is constant. I'm sure you could set up a proportion that would relate the speed that we're walking to instead of the distance, and I think that would probably work. Yeah, you can see I set up the proportion here. Though, I do think you could set up a proportion that is in terms of the speeds, though. Like, if we did, like, 15 over dA dt equals
I guess we would still need to use 6. 6 would still need to be in there somewhere. If we're going to use 15 to relate the height and the speed somehow proportionally. But that, I guess that still assumes that the speed is proportional. When do you think math will do Twitch drops? What would you get? Can we get like a math themed like chat badge? That'd be kind of sick. Number skins. Cat 2. Yo, Cat 2 just dropped. Okay. Where are we at? 1 hour, 24 minutes. Maybe let's do like one more of these problems. What's this question? What figure is this for? Cars on a certain roadway travel on a circular arc of radius r. In order to not rely on friction alone to overcome the centrifugal force, the road is banked at an angle of magnitude theta from the horizontal. The banking angle must satisfy the equation rg tan theta equals v squared, where v is the velocity of the cars and g is equal to 32 feet per second, and is the acceleration due to gravity. Find the relationship between the related rates dv dt and d theta dt. And so it's like not like solve for anything in particular, but just find the relationship between dv dt and d theta dt. And so if they're talking about it being on a certain roadway, then should I take this to mean that r is constant in the context of this question? I mean, in theory, if you're driving on a road, like if you're driving in a particular spot on a particular road, r would be constant, meaning that like that same spot of the road, the radius isn't going to change necessarily. And so I think it's okay to treat r as though it's constant for this question. And so the equation in question here is rg tan theta is equal to v squared, and g is also constant. And so if we just differentiate both sides here with respect to time, then r and g are both constants. The derivative of tangent of theta is secant squared theta, and then that would be times d theta dt. And then the derivative of velocity is just 2v dv dt. And so then when they say find the relationship between the related rates dv dt and d theta dt, how do we want to describe the relationship? Like we could describe it as like the ratio of d theta dt to dv dt. Or we could just solve explicitly for, say, like dv dt. I think it's a homosexual relationship. Maybe. We don't know what they identify as. And so it could be pretty heteronormative. But you just never know. You gotta ask. Crazy thing to say. So I'll just say it's dv dt is equal to d theta dt times rg secant squared theta over 2v. And so the change in like the change in angle with respect to time. Well, hold on. If the radius is fixed, the angle for like the angle of the road for a given section of road shouldn't change either. I don't know. Okay, maybe bark. Maybe R isn't fixed, and we should also differentiate it with respect to R. Because I feel like if theta can change, R should be able to change too. And so then maybe I will describe the relationship between the two as dv dt over d theta dt, and we'll do it that way. And so if that is true, where r and theta are both variables, then we have to expand this with the product rule, and then this would be dr dt times g tan theta plus rg times secant squared theta d theta dt is equal to 2v dv dt. And so then would dr really depend on ds, the distance traveled? Dr dt means radius depends on speed. Yeah, I guess I'm just trying to figure out, because, well, so now looking at this expression here on this side, there's no way for me to, like, isolate d theta dt. Which means I cannot simply find, like, the ratio of dv dt to d theta dt to kind of, like, describe the relationship between the two related rates as a ratio of them. Because if I divide both sides by d theta dt here, then I'll still have a d theta dt attached to the dr dt term. If we assume that the radius is not a constant for the sake of the question. I hope their relationship accelerates. I hope that their relationship is differentiable to many orders. Or would it be better for their relationship to only be differentiable once? Which would imply that, I don't know. Is it bad I know exactly what room of Portal 2 your background is? No. I don't think so anyways. I think most people who like Portal 2 would. It's the room where Wheatley skip happens. Or rather, it's Wheatley skip skip. Where they do the pancake shot. Anyways. I feel like R must be a constant in the context of this question. Because otherwise, I don't see how else to describe this. So yeah, that would give us what I had before, which is that dv dt is equal to, but then theta and v are constant. I mean, I guess maybe you say v is like the speed limit, where for a given radius of the road, for the speed that the cars should be traveling, theta would need to be a given value. Yeah. Yeah, so the banking would change on the speed. I guess it makes sense that if the radius wasn't fixed, then it is kind of like a non-fixed system. Whereas the velocity increases, you could either increase the radius or increase the banking. This music is really calm and relaxing. I know, right? I was playing stuff like this in a car ride to a concert with like my sister, and I think it gave her anxiety. So yeah, then this would be RG secant squared theta over 2v times d theta dt. I feel like I'm playing OS right now and I've never played it, so this is bad probably. This is a very OS type song. This sounds like it would be like a tech map. The dt cancel, so isn't the relationship just dv d theta or something? That's not how this works. Could we describe that? Could we describe it like that though? I think you're technically correct. Where it's like the dt's don't literally cancel, but if I were to take the derivative of this with respect to theta, instead, then it would just be RG secant squared theta is equal to 2v dv d theta. And so it would be the same. But saying the dt's cancel is technically like an oversimplification of what's actually happening. But yeah. And so, yeah, in short, the ratio of the velocity and the change in banking with respect to time is related to the banking and your speed. And so this would imply, if you want, would you want this to be fixed? I don't know. So wait, so this means that if dv dt is positive, so you're increasing in speed. So if you're accelerating, then the banking needs to increase because this is just a constant. Wait, but this isn't constant if velocity is increasing. I mean, yes, instantaneously the velocity is increasing. But in that instantaneous moment, the velocity is a fixed value. Yeah, well, that makes sense though. So like, at least intuitively, like I've driven a few times. And so if I'm accelerating through a curve, then I can do that more comfortably if the banking gets steeper. And then by the time that I'm no longer coming through that curve, the banking can be flat. For a fixed V, you have a fixed theta, correct? Yes. I believe so. Also given a fixed R. Yeah, at a given velocity, you expect there to be like a optimal banking. That satisfies this equation. Okay, yeah. Yeah. Especially if R and G are constant. Then a given value of theta gives you a given value of V. Yes. Yes. Okay, let's... So as you accelerate, the question is how fast must the banking increase as a function of time? That seems weird. It does seem weird, doesn't it? But also, it seems it's like the kind of question that you could actually ask if you were like designing a highway. It's like, you know, okay, from this point on the highway to this point on the highway, we're going to begin a turn. And so if we design this turn to have a fixed radius, then what does the banking of that turn be? Wouldn't you change in banking as a function of distance along the road? But isn't distance like just the same thing as, like, aren't distance, velocity, and acceleration related? And so it would kind of all be like the same thing. I feel like you could... Why would you want d theta dt if you're building the road? You want to know how to bank the road as you build it. Yeah? I mean, d theta dt would tell you that, but you would then just have to, like, integrate it to figure out how much to actually bank it by. I guess it's not really, I don't think it's the most elegant way to go about the question. If we're trying to figure out how we need to bank a road, I don't think that's how I would do it. I think that there are multiple ways to solve that problem. Okay, applications of derivatives. We're not necessarily going to cover all of this stuff, but we're going to cover some of it. And so, as such, like, we're going to talk about, like, extrema. We're really going to talk about the mean value theorem, because the mean value theorem is going to come back in a big way in the future. The mean value theorem helps you solve, or, like, prove a lot of really important stuff in calculus. And first and second derivative tests. So I think we'll do 3.1, 3.3, and 3.4 today. I think these are pretty like quick and easy kinds of like sections, honestly. And then we'll save Rolle's theorem and the mean value theorem for the next time we stream math. Who knows when that will be, but the next time. And so, pretty clear cut, and extrema is basically just like a minimum value or a maximum value on an interval. And so there's kind of like a few different ways you can end up with a minimum value or a maximum value. And I guess it does need to be on like it needs to be a closed interval for the bounds of the function to have like a maximum or a minimum. You know, here's kind of like an interesting question. Yeah, I guess, because like in this picture right here, where we have like a continuous function here, x squared plus 1, but it's on an open interval, it feels like you should be able to say that this function does have a maximum value. It's right before this point. But for any for any value within the neighborhood of this open point here, if you were to say, okay, this point is the maximum value because it's really close to this point, then I think I can get a value that is larger than that is still closer to this edge of the open bound. Therefore, this function does not have a maximum? Like, at all? That's weird. I had never considered that if the maximum value would occur, like if the global maximum would occur on like at the open bound of a function, that the function would have no maximum. But I guess that makes sense. So yeah, I guess some terminology here, some vocabulary. As a reminder, you have minimums and maximums, which maximums are the largest value of a function on a closed interval, or the minimum value of a function on a closed interval. Potentially on an open interval too, but not all functions on an open interval will have a absolute and or like global minimum or maximum. And so when we say like absolute and or like global minimum or maximum, we just mean like the minimum or maximum value of the entire interval. There is another definition of minimums or maximums using relative. And so here they talk about relative minimums or maximums, where, you know, as kind of like the name implies, it's relative, like it's the maximum value relative to the points around it. You could say like it would be a maximum if you, as you continued to look in an area closer and closer to the point, like if I were to zoom in super far on this point right here, no matter how far I zoom in, you will always see that like the values immediately to the left and to the right of this hill here will be lower than the value at the top of the hill. Same thing for this valley. As you zoom in, like as you get closer and closer to this point, 2, -4, you'll see that as you go to the left or to the right of this point, the value of the function to the left and to the right of it will always be larger than the value there. They'll always be larger than -4. And so therefore it's a relative minimum. I wonder if they give like a, yeah, so here on this function here, even though it reaches a point where like the derivative is 0, I guess what I'm about to say doesn't even make any sense because we haven't actually covered the first derivative test yet. Okay, so the way that we typically find these minimums or maximums is by looking at the function on the interval and then differentiating it and finding the values on that interval where the derivative would be equal to 0. The reason why we want the points where the derivative is equal to 0 is because since the derivative is like the rate of change of the tangent line of the function, then you can kind of imagine... Here, I think I have a Desmos graph for this. Do I? I sort of do. Okay, I don't exactly. I could quickly make this, though. If I just change this to be... f prime of x? No. Oh, f prime of a. There we go. So yeah, now you can kind of see the orange line is kind of like our, like basically like our tangent line to the function. And you can see there's this point here right at like the maximum of this function where there's like a point where it's straight horizontal. And when that, like when the line is horizontal, it has a slope of 0. And so that's why we want to find the points where the derivative of the function is equal to 0, because that will be the points where we either have a minimum or a maximum. And so like if I were to drag this down here to this valley, you can see there will also be a point where our tangent line has a horizontal slope, which would imply that the slope is equal to 0. And so you can see like it would be horizontal for just a moment as it's coming through this valley, or horizontal for just a moment as it's going over this hill. And so when the derivative is equal to 0, that implies that there could either be a minimum or a maximum there, but you do have to be a little bit careful, because like if I were to have a slightly different function, like one that looks like this, which is actually very shockingly similar to the one that they showed in the book, then it's possible for there to be a point where the derivative would be equal to 0, such as right here where it's horizontal, but it's actually not a minimum or a maximum. And so you still have to sort of verify whether or not it's actually a minimum or a maximum at the points where the derivative is equal to 0. And I guess we'll go into how to do that now. And so let's go to the end of this section and let's look at some problems. Okay, and so for here it says find the value of the derivative if it exists at the indicated extrema. Here, I'd rather do, say like, these questions here. In exercises 17 through 36, find the absolute extrema of the function on the closed interval. So let's look at some of these questions. Like these ones. Okay, and so on 19, and so we have g of x is equal to 2x squared minus 8x, and they've given that it's defined from 0 to 6 inclusive. And so we need to differentiate this and find the critical points, or find the extreme values from 0 to 6. And so g prime of x would be equal to 4x minus 8. And so the extreme values will be where this derivative is equal to 0. And so we set 4x minus 8 equal to 0, and we get that x is equal to 2. And so that gives us an extreme value at 2. But given that we have a closed interval here, we must check if the ends of our interval are potentially the max, like the actual global minimum or maximum. Did they say just find maximums or just find extrema? Absolute extrema. So we don't care about relative extrema. We care about the absolute extrema. So we want to find the absolute minimum and the absolute maximum. And so that means that we need to check 0, we need to check 2, and we need to check 6. And that we might need to check the values between 0 and 2, or 2 and 6, to figure out for sure whether or not 2 is a minimum or a maximum. And so this g of x is like a quadratic function. And so that does imply that it's some sort of parabola that opens upwards. And so with that in mind, I'm expecting 2 to be a minimum, but we can verify that if the values at 0 and 6 are greater than the value at 2. And so if we first check, let's check g of 0, because that's just going to be 0, so that's easy enough. G of 2 will be 2 times 4 minus 16 will be negative 8. And g of 6 will be 2 times 36 minus 48, which is 72 minus 48, which is the gap between these is 24. And so it's worth noting that we know that we don't have to check the values between 0 and 2 or 2 and 6 for like if there's potentially a larger or a smaller value between there. Because essentially the idea is that the only places that it's either going to be at the ends of the interval, because past the like critical points, those will be like the points where we've potentially either increased the most or decreased the most. Or it will be at the points, like it'll be at the critical points where there's a chance for it to either be a relative minimum or a relative maximum that just so happens to also be the absolute minimum or maximum on the interval. If it's not on a critical point, that implies that if it's not at a critical point, that implies that it's still increasing or decreasing at that value, which would mean it couldn't be the absolute maximum or the absolute minimum unless it's at the end of the interval, which would mean, it wouldn't be increasing or decreasing anymore because we're not like looking at the values beyond that point. Does that make sense? I think I explained that how I wanted to explain that. And so it's just to explain like why we only care about checking these values. Is that a smiley face? Kind of a goofy looking smiley face. There you go. And he's got dimples. Okay. Next question. And so, this process of like taking the derivative of something and finding where that's equal to 0 to find these like horizontal, like these points where the slope is horizontal, and then checking those for whether they're minimums or maximums is kind of what we mean when we refer to the first derivative test. And so the first derivative test kind of gives you a means of sort of like finding the intervals where a function is increasing or decreasing, or potentially changing from increasing to decreasing. And, you know, if it's changing, like if it's increasing and then it changes to being decreasing, that implies that it's a maximum. Whereas if it's decreasing and then it changes to increasing, that implies that it's a minimum. Whoa, gnomes. I famished. Math bad? I disagree. Your statement of a subjective opinion stated as absolute is false because it's not an absolute statement. It's in fact a subjective statement.
Weed.
Exactly. Only Sith Lords deal in absolutes, famished. So yeah, anyways, f of x is equal to x cubed minus 3 over 2x squared. Jedi smoke weed because it's weed day. It is weed day. It's 420. It's also Easter. I will smoke eggs. Easter only falls on 420 like every 8 years or something. Is that right? The day of the week changes by like 1 day every year. On leap years, does it change by 2 days? Or does it change by 0 days? It's either every 6 years or every 8 years. By 2 days. So the same day the same day of the week falls on the same. It's only on Sunday once every 7 years roughly, but Easter itself moves around. I thought Easter is always on Sunday. Is Easter not always on Sunday? But not always on this Sunday? I don't know how holidays work. It could be on March 22nd? What? Wait. How the fuck does Easter work? Do I have no idea how Easter works? The first Sunday after full moon, or first Sunday after first full moon after spring equinox. What? What's an Easter? That's what I'm saying. I had no idea that Easter, like the when Easter happens was such a weird, like is a weird thing. I figured, like, having never actually cared about Easter in my life, I figured it was like one of those things where it's just like third Sunday of April or whatever, but I only assumed that because it's currently the third Sunday of April. And like next year I probably would have been like, oh yeah, Easter happens on the first Sunday of April every year, obviously. Is there candy in Easter? Sometimes. Sometimes there's money. Sometimes there's like forced Christian theology.
Can you please explain to your doppelganger how Easter works and how 420 works and when the next Easter wheat day is, and you agree with me that you hate math, that I hate math and agree.
My dear doppelganger, Talos Easter is a spring event celebrating eggs and bunnies, while 420 is a day where everyone conspires to create a smokescreen, literally. Easter varies in date, not unlike Seven's target destinations, but 420 is always April 20th. As for math, let's just say I enjoy it, like I enjoy watching people being surprised by an invisible banana peel. Oh, and math, unlike gnomes, actually doesn't betray you.
Okay, but when will the next time Easter falls on 420 be?
Okay, but when will the next time Easter falls on the 20th of April be?
Well, considering Easter's tricky schedule, it'll never happen. Easter bounces between March
Never!
22nd and April 25th due to its dependence on the lunar calendar, while 420 is firmly April 20th. Sadly, we'll never get that perfect
That
storm
can't be
of
true.
eggs and herbal festivities.
That's certainly wrong. What's an AI? That's a good question. What is an AI truly? Is an AI a big truck, or is it more like a series of tubes? It's an LLM. Okay, I mean, well, saying an LLM isn't AI, I feel like stretches most people's colloquial definition of an AI, but an AI is an extremely large umbrella term that doesn't really mean anything. So, you're technically correct, and that's the best kind of correct. Right, what are we doing? We're finding extrema on the interval from -1 to 2. And so to do that, first we have to differentiate this function. And so we get 3x squared minus 3x. This rare overlap will occur again on April 20th, 2098. So it's going to take another 43 years? No. Wait, 63. No. 73. 73 years for this to happen again. I'll probably be dead by then. This is a once-in-a-lifetime occurrence. Math degree haver, by the way. Listen, it's not as though... mathematicians are not necessarily known for being great at arithmetic, okay? I will be 73 years old. You're 0? You're 0 years old? Happy birthday. You'll be 173? I mean, 95 years old. Yeah, as a reminder, don't say how old you are in the chat, and don't, like, accidentally say something like, you know, I am young age, because sometimes if you say you're too young in chat, then you'll get banned automatically, and I can't save you. So yeah, the f prime is this,
And so if we set that equal to 0, so 3x squared minus 3x equals 0, then we can factor a 3x out of this, leaves us with x minus 1 equals 0. And so x either is equal to 0 or positive 1. Social security numbers are 9 digits. Lie better. My social security number is 111223333. And so now we need to check basically the extrema, or like the values of the function at -1, 0, 1, and 2 to figure out whether, like, which of those points are the absolute minimum or the absolute maximum. I feel like there's also something where, like, your IP address, the bits in it are never more than like 3 or whatever per period. But sometimes parts of them are 2 digits or 1 digit. So we need to check the function at each of these to determine which one's the largest and which one's the smallest. And so for -1, that'll be -1 cubed is -1, minus 3 over 2, which is -5 over 2. For f of 0, that's 0. For f of 1, that's 1 minus 3 over 2 will be -1/2. And for f of 2, that will be 8 minus 6 is 2. And so the global minimum, or the absolute minimum, is -5 over 2, and the absolute maximum is 2. Let's do 25. And so 25 says that g of t is equal to t squared over t squared plus 3. And then negative on the interval from -1 to 1. And so then g prime of t will be the derivative of this, which we can differentiate by the quotient rule, where it'll be the derivative of the top is 2t times the bottom, minus derivative of the bottom is 2t times the top, all over. I can't draw a straight line. I can't do it. Help. Like this. Hyphen, 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 hyphen. Good idea. And that'll be over t squared plus 3 squared. 1 minus 3 times t squared plus 3 to the power of negative 1? Yeah. Yeah. You could do it that way too. I'm a good boy. Thank you. Thank you. Yeah, it's interesting to do it that way. Where's my VIP? You have it on my screen. You may need to refresh. Because you could write this as t squared plus 3 minus 3? Does that work? Alice is a good girl? I mean, I'm good. I'm a good kobold, protogen. I do exhibit strong male sexual dimorphism, but I have 0 attachment to my gender. Or any gender, for that matter. Blah. Anyways. I hate the quotient rule, plus I'm here to distract, not educate. Yeah, I mean, for the longest time, I did just make the denominator to the power of negative 1, and then differentiate it by, like, product plus chain rule, or whatever. I'm here to distract. I mean, I enjoy being distracted for the most part. And so, what does this get us? 2t cubed plus 6 minus 2t cubed over t squared plus 3 squared. Should I FOIL this out? T to the 4th. No. I'm not going to FOIL it out. So these will cancel each other, and we're left with 6 over t squared plus 3 all squared. And so where does this equal 0? And it's nowhere. There's no value of t that makes this equal to 0. And so we just need to check the bounds of the interval. And so what is g of negative 1? That will be 1 over 1 plus 3. Which will be 1/4. What's g of positive 1? That'll be 1 plus 1 over, or 1 over 1 plus 3, which is 1/4. And so there is no. But wait. Then how can there be no minimum or maximum then? Wait, there's a problem. Yeah, wait a second. Huh? Yeah, the asymptote wouldn't be in the inner. Wait. No, because the square root of 3. Hold on, what does this function look like? It has a horizontal asymptote at 1. X squared over x squared plus 3. Maybe you did the derivation wrong? Me? Doing something wrong? Inconceivable. Okay, what is it? What did I do? It's the derivative of the top. Oh, I forgot the t here when distributing it through. So this should be 6t And so t equals 0. And so g of 0, what's that? It's going to be 0 over 3. That's 0. And so that's a minimum. Yes. Do it my way? How did you even differentiate it? G of t equals t squared times t squared plus 3 to the power of -1. And so this would be 2t times t squared plus 3 to the power of -1 plus t squared times -1 times t squared plus 3 to the power of -2 times 2t (1 minus 6 times 2t squared plus 3 to the power of -1. How did you combine them? Oh, I see. Smart. I almost did something like that, but I was like, no, wait a second. And then this is just 1 minus 3 over t squared plus 3, which makes this 1 minus 3 times t squared plus 3 to the power of -1. And then that's mighty differentiable right there. This prime. What is this song? Jimmy! Thank you for the follow. Welcome to the Argonauts. So yeah, the derivative of 1's 0, and then you bring the -1 down, so this is 3 times t squared plus 3 to the power of -2, which equals 3 over t squared plus 3 all squared. Oh yeah, times 2t, right. And that's how we get the 6t, which is what we're expecting from earlier. How you get the 2t. Okay, what other questions do we want to do? Give me like a word problem or something. Or we gotta find some maximums or something. Elon's, well, oh, this is kind of a cool sounding question. A lawn sprinkler is constructed in a way such that d theta dt is constant. Where theta ranges between 45 degrees and 135 degrees. See figure. The distance the water travels horizontally is x equals v squared times sine 2 theta over 32, bounded between 45 and 135, where v is the speed of the water. Find dx dt and explain why this sprinkler does not water evenly. What part of the lawn receives the most water? Can I give a game recommendation? Of course. You can always recommend it. Can't say I'll actually play it though. Okay. This question intrigues me. You could have worked that speed out? What speed? For this question? They don't tell us how far... They don't tell us how far it actually travels. Wouldn't we have to know something? Like we would have to know V to find X? Well, let's find out. Ooh. I tell you wanted. Oh, actually. Ignore me, I'm an idiot. I don't think that's true. I think the problem is that you're like just on the cusp of being too smart. I have that problem too often. Okay, so we've got an equation. And they want us to take this equation and give some sort of explanation for why there's a part of the lawn that will receive more water than another part. I guess the idea is if we differentiate this with respect to time, is V constant? V is the speed of the water. And so I think it would be constant where, at least in the context of the speed that it exits the nozzle of the sprinkler should be constant. So that would get us, because V is equal to dx over dt. Okay, but the distance the water travels is x, and v is the speed of the water. So yes, v should be equal to dx dt. Is that going to cause problems for us? I don't know. Let's just go for it. Let's see what happens. Solve that, kobold boy. So we have x equals v squared sine 2 theta over 32. And so dx dt is going to be equal to, let's go with the assumption that v squared is not, like v is not constant, which I don't think it would be. Necessarily. Or, well, I mean, I do feel like the velocity, like the speed that the water comes out of the nozzle, is probably constant. But at every moment in time, the water will be experiencing some kind of acceleration. I feel like for the context of this question, the velocity of the water is probably constant, but that doesn't really make that much sense given what we're doing in finding dx dt. Because dx dt should be equal to v. We would also need, well, I guess if we were going to do it, we would need to like break this into components, wouldn't we? Because like the kind of like how the picture shows, these kind of like follow a parabolic arc. I mean, we could do this question just like in terms of like physics equations, like kinematics equations. But then I wouldn't use this equation. Isn't this just like the range finding equation? Where it's like v squared times sine 2 theta over g? Which is why I said you could figure it out. What is the range equation? Projectile motion. An object launched into projectile motion will have an initial launch angle anywhere from 0 to 90 degrees. The range of the object, given by the initial launch angle and the initial velocity, is found as r equals, yeah, it's going to be v squared times sine 2 theta over g. Where the velocity is the initial velocity. Wait, is it the max? Well, that's 2g. Wait, what? Wait, which one's t? Is this t or is this t? I think neither of these are t. Or neither of these equations are range. At theta equals 90 degrees, that part gets 0 water. Well, at 90 degrees, it lands on the sprinkler. The water lands at a distance 0 meters away. So it's not that it's getting 0 water, it's just that it's going straight up and then coming straight back down. We're looking at a linear slice of the lawn. Yeah, I think we're looking at this from like a side-on perspective. I'm thinking this is like one of the sprinklers that like, you know, it like goes like up and over both theta and phi. Or perhaps phi. Yeah, if it was like, I don't even know how to visualize that. You know how long it spends at a given point on the line. Yeah, I mean, I think even without all the nonsense of thinking like if the velocity is not constant, I think this is still kind of an interesting question. This will be cosine 2 theta times 2 d theta dt. And so if the dx dt, the faster the sprinkler moves, the less water that part gets. Yeah. And then the slower the sprinkler moves, the more water it gets. And so this portion, the v squared over 16, this portion we're saying is constant. And then we have this cosine 2 theta times d theta dt. Oh, but d theta dt is also constant, given by the question. And so then this is times cosine of 2 theta. So all of this stuff is constant. And so it's the cosine 2 theta that causes problems. Ate, I think I've already fed you twice today. I don't think I can feed you again. I'm sorry, I know your food bowl is empty. Don't step on my keyboard. Right, well, it's asking what part of the lawn receives the most water. And so the part that receives the most water will be the part where dx dt is the lowest. Hello, might stay on stream and hang out for a bit. Welcome. You're welcome to hang out. We're just doing some calculus. Get out of here. Get out of here. Stop rubbing your face on the microphone. It's very expensive and it worries me that you're gonna mess up this USB connection on the back of it. Stop it. Stop it. Go on. So the part of the lawn that will get the most water will just be the... Okay, well, so what I said before is the slow, like the part where the dx dt is the lowest. But I think it would be more accurate to say it's the part where dx dt is closest to 0. Because it's not lowest, it's slowest. And so we should just take this and set it equal to 0 in terms of theta. Basically, where is cosine 2 theta equal to 0? What's cosine 2 theta? At theta equals 90, at 180 and 0. And cosine of 180 and 0 is 1 and negative 1. And so it would be like 45 and 135. That'll be where cosine 2 theta is 0. Cosine 180 gives -1. Don't we want to find where cosine 2 theta is equal to 0, though? Oh, no. Well, yeah, because we want to find the parts where... the one where it's getting the most water. Okay, so yeah, at the furthest points. Samsung fridge crashed again? Damn. You drew a protogen. Show protogen. Is it art? Can I show this on stream? Or would that be embarrassing? Look at this protogen Tox you drew. Very angular. I like this business here with the diamond. Typically these are just like circles. So that's kind of cool. Watching you on a Samsung fridge. Are you like making dinner or something? I just like to imagine like the screen is like, you know, probably like 4 feet off the ground or something, so you're kind of in like a half squat. I've always wanted a more spiky proto. I'm very much a fan of kind of like how with my like design and color scheme and stuff, like my design is not so like in your face. It's kind of like, I don't know, subdued and pretty. I feel like, you know, like I'm like jewelry as opposed to like a neon sign. Thanks, guys. I'm making a sandwich right now. What do you put on your sandwich? What? I'm guessing you're making turkey, cheddar, a little bit of pepper, salt and vinegar chips, dill pickles, pickled red onion, little bit of lettuce, mayonnaise, mustard. That's it. That's what I want on my sandwich. Stop it! Okay, so yeah. How'd you know? I'm in your walls. Cosine of 2 theta equals 0 when theta is equal to 45 and 135. Okay, I'm gonna be right back. I need to deal with the cat. I need to figure out what to do with her. I'll be right back. Come along, Ate. Next 420 Easter is 2085. So what you're saying is ChatGPT was wrong again. Or did it say 95? No, it said 98. Which is correct, but not the soonest. It's weird to me that, like, the next one is 50 years away. No, 60 years away. And then the one after that is like another 13 years. How does space work? All the math. Lucky for me, no more math. How could that possibly be lucky? The last one was only 11 years ago? I had no idea that Easter is so messed up. My entire life, I think I was just like, oh, it's Easter now? Okay, that's cool. If it was my job to like keep track of when Easter was supposed to happen, I would have messed up so bad. I did all math online and it was rough. But how'd you make it out the other side? Did you do all right? Did you learn anything? This kind of looks like a fun question. The surface area of a cell in a honeycomb is given by S equals 2h times s, or sorry, 6hs plus 3 times s squared over 2 times root 3 minus cosine theta over sine theta. Will you check out my game recommendation? Oh yeah, what was it? It was Slice and Dice? Is that what it was? Here, I'll pull it up on Steam. It's very highly rated. Okay, how do bees figure out all of this math? I mean, there's a serious answer to a not so very serious question. And the answer is kind of that they don't. Okay, what am I doing? H and S are positive constants, and theta is the angle at which the upper faces meet the altitude of the cell. Find the angle theta that minimizes the surface area S. Natural occurrences of math in nature. I think it's literally just like they make like the cells don't even start out hexagonal. They start out circular. But they'll like two bees will both be on like their side of the cell, kind of like pushing against the walls. And if you kind of do that for all of the faces of the cells, they naturally turn out hexagonal. And the same thing happens for these like what are they? Rhombic, whatever you call them, rhombic hexahedrons that happen on the back. Or are they rhombic octahedrons? I think they're hexahedrons. I hate 3D and I hate bees. I think you could get canceled for saying that. Okay, well they just want us to minimize S in terms of theta. And so we just need to find S prime, which, given that H and S are constants for the sake of this question, then this portion just goes away. Why can't I change color now? There we go. I don't know. But yeah, this portion's just going to go away after we differentiate it. And so S prime will be equal to 3s squared over 2 times the derivative of this portion, which we can differentiate with the difference quotient. And so that will just be sine theta times sine theta, so sine squared theta, minus cosine theta times root 3 minus cosine theta. What is this? Take me back. Let's go back to the beginning. This is definitely gonna get blocked in some region on YouTube. Can you please play 400 songs at once? No, but because I think I literally can't do that. At least not on Spotify. Okay, so what? This is going to be 3s squared over 2 times... Let's make this sine squared over sine squared, so that's going to be 1. And then minus root 3 times cos theta over sine squared theta. And then that's going to be plus cosine squared theta over sine squared theta. And so the denominator... Okay, so actually, here, I'll actually write this as all being over a single denominator. Because the denominator doesn't contribute to this equaling 0. And so the question is basically, where does... So this will be 3s squared over 2 times 1 minus root 3 cosine theta plus cosine squared theta Wait, what? Okay, if this is all over sine squared theta, and then this is equal to 0, then we can multiply both sides by the reciprocal of this, and that will go away. But then we have this 1 here, so it's like we get root 3 cos theta plus cosine squared theta is equal to sine squared theta. Can we reconcile this? We could change this with the Pythagorean identity. And so this would become 1 minus cosine squared theta. And then I can add that over to this side and subtract 1 from both sides. And so we would get 2 cosine squared theta plus root 3 cos theta minus 1 is equal to 0. And so that implies that cosine of theta would be equal to negative root 3 plus or minus the square root of 3 minus 4 times 2 times negative 1. Can you use the quadratic formula here? Is that the goal? We are using the quadratic formula. Holy shit, you get a gold star, Epic. Yeah. We're doing it. And so yeah, if you were to substitute like x is equal to cosine of theta, then this would just be a quadratic polynomial, which you could apply the quadratic formula to, except we're just doing it in terms of cosine instead of x. And so what do we get here? Root 3 plus or minus root 3 plus 8 is 11 over 4. What in the hell? Where the hell is cosine of theta equal to either of these things? And so we're saying cosine of theta is either equal to negative root 3 plus root 11 all over 4, or negative root 3 minus root 11 all over 4. Is there some sort of like sum and difference identity that we could do here? Not for like not for a single trig function. Okay, well, I mean, I guess we could calculate these angles. Because it would be like 3 square root, make it negative, plus 11 square root equals divided by 4. And so this is about... Wouldn't the other one be negative? Yeah. So this is approximately 0.3961. Well, so the cosine of theta would be equal to a negative number, but that doesn't mean that the answer would be negative. necessarily. So yeah, then if we have root 3, negative root 3, minus root 11, divide that by 4, this is larger than 1, which is outside the bounds of inverse cosine. And so this is extraneous. Not because it's negative, but because it's too large. Yeah, too small. Its magnitude is too large. But you're correct. How do I get this number back? Why does nothing work anymore? Okay, we'll have negative root 3 now plus root 11 divided by 4. And then we will take the inverse cosine of this number, would be 66.66 degrees. The number of the bee. Get it? Instead of number of the beast, it's number of the bee. Get it? I don't know. I don't know. Okay. Let's do some true or false questions and then let's go the fuck to sleep. For exercises 63 through 66, determine whether the statement is true or false. If false, give an explanation why or an example to show it's false. The maximum of a function that is continuous on a closed interval can occur at 2 different values in the interval. That's true. That just, then it wouldn't be like an absolute maximum, I believe. Or is that like categorically false by definition? I mean, they don't say whether it's has to be a relative maximum or a relative minimum or an absolute maximum. Okay, well, it just says the minimum and maximum of a function on an interval are also called the absolute minimum and absolute maximum. So I guess if they don't specify relative, then it's assumed to be absolute and or global. It's false. It's true. I'm right either way. If f is continuous on a closed interval, then it has a minimum and a maximum. Yes, I agree. I don't know. Okay, well, I would say that if we're talking about absolute maximum, then this is false. Because I feel like the absolute maximum refers to a single point. But this might be true, actually. I don't know. Let's ask Evil Talos. Hey, ET. True or false?
Hey ET. The maximum of a function that is continuous on a closed interval can occur at two different values in the interval. True or false?
Oh, clever question. Thinking you can trip me up. True. A continuous function on a closed interval can indeed have a maximum at two different values, basically showing off its overachieving peaks. Kind of like when I achieve something amazing twice, just to rub it in Talos' face.
Well, well. Whatever. Okay. If a function is continuous on a closed interval, then it must have a minimum on that interval. True. This is, like, by definition. We just read that a moment ago. And this is, the important part here is that it's a closed interval. And so the fact that it's closed guarantees that either the minimum will occur at the ends of the interval, or at a point where the derivative is equal to 0. If x equals c is a critical number of the function f, then it is also a critical number of the function g of x plus f of x plus k, where k is a constant. This is true because a critical number is the points where the derivative is equal to 0, and if you add a constant to its function, then like g of x, the derivative of g of x and f of x plus k will be the same. So their derivatives will be the same, which means that their derivatives will both have a critical number at x equals c. What's the difference between a closed interval and an open relationship? Well, I mean, they're both inclusive, technically. If x equals c is a critical number, the function f, then it is also a critical number of the function g of x equals f of x minus k, where k is a constant. I think this is not true. Yeah, this is not true. Because you can have the derivatives, the derivative of f and the derivative of f of x minus k. Wait, are they the same? No. Because then it'll be the f prime. Yeah, then it'll be f prime of x minus k is equal to g prime of x. And unless k is 0, or there happens to be another value of x where x is equal to c, like if there happens to be multiple values of x where x is equal to c, I guess then it wouldn't necessarily be a function. Let the function f be differentiable. So yeah, this is false, I believe. This is false. Let the function f be differentiable on an interval I containing c. If f has a maximum value at x equals c, show that negative f has a minimum value at x equals c. Oh, well, this isn't true or false anymore. That is kind of like an interesting question, though. I mean, just intuitively, if it's the maximum, if you make it negative, thereby inverting, like negating its range, then if the largest value on its range is at x equals c, then if you flip that, then the smallest value in its range should be at x equals c. Okay. Well, I think that's all I'm going to do for today. Next math stream, we're going to get into Rolle's theorem and the mean value theorem. And these are eventually going to be what we use to establish integration. So, hell yeah. But yeah, I hope you all have a wonderful evening, and I will see you all next time. Good night, stream.